Now let us see the wire drawing operation. Let us see the wire drawing operation. Okay, so you can see on the secondary screen a setup for wire drawing. What we are having is, we are having some initial coil. This initial coil is pulled. It is drawn through a die, and inside the die the cross-section area of the initial workpiece is going to change. So what is there inside the die? So if you look at the die from inside, it will appear like this. This portion the workpiece will enter, and from here the workpiece will come out. So we are pulling the workpiece from here. We are applying a tensile load on the workpiece from this direction. So this entire die can be divided into 4 zones. This is the first zone. Here is the second zone, third one, and the fourth zone. Okay, so entire die can be divided into four zones. You can see in the second zone, at the entry, we are having the initial cross-section area, and at the exit, we are having the final cross-section area. In zone 2, at entry we have the initial cross-section area, and at exit we have the final cross-section area. It means whatever deformation is taking place, it is taking place in the second zone, right? Therefore, the second zone is called as deformation zone. Then you can see that in the first zone there is no contact between the workpiece and the die. The purpose of the first zone is lubrication. Whatever lubrication is needed, that lubrication will be supplied from here. Whatever lubricants are needed, that will be supplied at these points. Okay. Then zone 3. What is the purpose of zone 3? Okay. Please listen carefully about zone 3. What is the need of zone 3? Okay. If I have all of your attentions. So what happens is, whenever you apply load on a material, its shape will change, right? Its shape is changing because of 2 deformations. One is plastic deformation, obviously, and other one is elastic deformation. Okay. So when you remove the stress, what will happen is, whatever elastic deformation took place, that elastic deformation will try to recover. Okay. Now, if you want that elastic deformation should not recover, what you will do is, you will maintain the stress for some time. So when you maintain the stress for some time, what happens is, whatever elastic deformation was present, that elastic deformation will get converted into plastic deformation. Okay. That is the purpose of zone 3. What happens is, after causing the deformation, if you directly bring this zone, no load is acting on it. No load is acting on the workpiece. So the workpiece will try to go back to its previous size. And because of that, we won't get the actual size. So what we do is, we try to retain the load for some time, so that we are able to convert whatever elastic deformation was present inside the body into plastic deformation, and we get the desired size. Okay, that is the purpose of zone 3. Okay, so this is what is happening. Please take this. Okay, obviously, to get whatever desired size you want, you can cause more deformation so that it will come back to its original size, right? But for that you will have to do precise calculations, like how much you have to decrease so that after recovery it is becoming the size that you want. Okay, here by applying the load, by retaining the load for some time, if you are getting the desired shape, and it is okay, right? So zone 3 is called as sizing zone. Now what happens in zone 4 is, whatever lubricant you had applied in zone 1, that lubricant will get compressed between the die and the workpiece. Okay, it will have very high temperature and high pressure. All the lubricant will get compressed between the workpiece and the die. It will have very high temperature and high pressure. So there are chances that if you don't give this portion, if you keep it closed, then the lubricant will come out with high pressure, and whoever is standing in front of them, it may injure them. Okay, whoever is standing in front of the die, the high temperature lubricant may injure the person. So what we do is, here we apply covers, so that whatever lubricant we had used, it will get collected in the cover, and later we can remove the cover. So zone 4 is the safety zone. Okay, so these are the 4 zones, also called as relief zone. The zone 4 is also called as the relief zone. Okay, so you can see in the secondary screen the naming of different portions. The first region is called as entry region. Is generally a bell-shaped mouth. Please repeat zone 4. So what I am saying is, whatever lubricant you used, that lubricant will undergo very high temperature and high pressure. It will experience very high temperature and high pressure because of getting compressed between the die and the workpiece material. So if that lubricant comes out from the front, it will injure the person who is standing in front of the die. Therefore, we give some back relief here. And use covers. So in these covers, we can collect the high temperature lubricant so that it does not fall on the person who is standing in front. Okay. We have a diverging zone here. So this diverging zone will reduce the velocity of the lubricant. Okay. You can see on the secondary screen, the entry region is a bell-shaped mouth that does not contact the workpiece. Its function is to contain and to push the lubricant into die and prevent wearing of work and die surface. Then the second, that is the deformation zone, also called as the approach. The approach region is where the drawing operation occurs. It is cone-shaped with an angle normally ranging from 6 degrees to 20 degrees. Zone 3 is very small. Zone 3 is generally small. It will depend from material to material. Like for whichever material you want to retain the load for how much time. It will depend from material to material. Okay. Then the zone 3 is called as the bearing surface or land, determines the size of the final drawn workpiece. And zone 4 is the back relief. It is the exit zone. Then they have mentioned the angles. Okay. Zone 1 is the lubrication zone. It is also entry region, and here they have mentioned it is generally bell-shaped. So it is also called as bell. Okay. So better I dictate all this so that there is no confusion. If you see different books will mention different names. First zone is also called as entry region. It is also called as lubrication zone. It is also called as bell. Okay. So whatever is mentioned in the secondary screen about zone 1, that is okay. Only that much is needed. Okay. About zone 2, zone 2 is also called as deformation zone. Why? Because at the entry of zone 2 we have the initial cross section area, and at the exit of zone 2 we have the final cross section area. Okay. It is also called as sizing zone. Along with whatever has been mentioned in the secondary screen, it is also called as sizing zone. Okay. So along with whatever has been mentioned in the secondary screen, in zone 3 you can add, it is used for converting the elastic deformation present. It is used for converting the elastic deformation present in the workpiece into plastic deformation. It is used for converting elastic deformation present in the workpiece into plastic deformation. Okay. So in zone 4 you can write, the lubricants experience very high pressure and temperature. The lubricants experience very high pressure and temperature. The lubricants experience very high pressure and temperature in between the die and workpiece. When lubricant comes out of zone 3, because of high pressure, it may fall on the person standing in front of it. To avoid this, divergent zone will be provided. Divergent zone will be provided as an exit zone. Divergent zone will be provided as an exit zone. This is covered by using a cover. So that the lubricant coming out from zone 3 will be collected in the exit zone. And it will be drained out afterwards. Daniel is asking cover by. Okay, I have to continue from there, right? It is covered by using a cover. So that the lubricant coming out from zone 3 will be collected at the exit zone. And it will be drained out afterwards. Okay. Let's come back to this. Let us say that the initial workpiece that is entering, that I am calling as rod. And the final component that is coming out, I am calling as wire. Okay. The thing is, just in one die you will not be able to achieve good reduction. They will use multiple dies in series. And by going through all these dies, there will be some reduction. Okay. So, let A0 be the cross-section area of rod. A1 be the cross-section area of wire. So A0 is pi by 4 d0 square. A0 is pi by 4 d0 square. A1 is pi by 4 d1 square. Okay. Now here again what happens is, we'll be getting same formula for extrusion stress. Let us take this as sigma 2. Sigma 2 is equal to sigma F bar. Sigma F bar is average flow stress times of 1 plus V by V times 1 minus a1 by a0 to the power b. 1 minus a1 by a0 to the power b. Again, we'll have same expression for b. B is mu cot alpha. Now this time what is alpha? Here, this entire angle is 2 alpha. This entire angle is 2 alpha. So alpha is half of that angle. Mu is coefficient of friction. Alpha is half diangle. Alpha is half diangle. Okay. So if you memorize this formula, it will be useful for both wire drawing and extrusion. So it is recommended that you memorize this. Oh, I have written extrusion. Sorry, it is drawing. It is drawing stress, right? This is a drawing process. Drawing stress sigma 2 is equal to this. Okay, sir, can you please explain what is drawing is actually? See, I am having some initial wire. And I want to reduce its cross-section area. So what I'll do is, I'll insert the initial wire into the die. And then I'll start pulling the wire. When you are pulling the wire will experience some stresses because of coming in contact with the die. And its cross-section area will reduce. So this is the wire drawing operation. Okay, understood? Then Saurav is asking, sir, is this beta or B? This is B. It does not matter whether it is beta or B. Okay? It is just a notation. If you want, you can use beta. If you want, you can use B. I'm using B. Okay? Acha, what is drawing stress? Okay. Now Anurag is asking, sir, what is drawing stress? So Anurag, what is drawing stress is with how much stress you have to pull the wire, that is nothing but the drawing stress. Okay, that is nothing but the drawing stress. Wait, it will be slightly more clear later. Now Danish is asking, just because of tensile force instead of compressive, the rod is turning out into a wire. Okay guys, so this sigma 2 is the drawing stress. It means it is the stress by which you are drawing the wire. It is the stress by which you are pulling. It is a tensile stress. Sigma 2 is a tensile stress by which you are pulling the wire. But is it the stress because of which the wire is undergoing deformation? Is sigma 2 the stress because of which the wire is undergoing deformation? Is it? Is drawing stress the stress because of which the wire is undergoing deformation? Danish is saying die compression. Yes. Whatever shape is being changed in the wire, it is not changing because of the drawing stress. Drawing stress is just the stress by which you are pulling. Now, because of the pull, what is happening is the material is getting compressed. The workpiece is getting compressed. It is experiencing shear force. It is experiencing the tensile force. Okay, all these forces it is experiencing, and because of that, the flow stresses are induced. The flow stresses are induced in the material, and because of those flow stresses induced, the material is undergoing deformation. It is not undergoing deformation because of the drawing stress. By drawing stress, you are just pulling the wire. Because you are pulling the wire is experiencing shear stresses inside the die, and because of those shear stresses along with the tensile stress of the drawing, the material is undergoing deformation. Okay, so that is what I am trying to tell. Now Saurav is asking, in rolling we have friction, in extrusion we have ram, in drawing what is there pushing or pulling the wire? Okay, so Saurav's doubt is what is pulling the wire? Saurav, here we'll have a roller. The roller will keep on rotating. Okay, and this will get coiled on the roller. Because of the rotation of the roller, it is getting pulled. See, you can see on the secondary screen, there is a roller. It is rotating. Because of the rotation of the roller, it is getting pulled. Understood? So how many of you understood the point that sigma 2, the drawing stress, is not responsible for the shape change, This is just responsible for the pull. But because of undergoing through the die, the wire is experiencing stresses, and the stresses that it is experiencing, because of those stresses, the material is undergoing the shape change. Have you understood this point? Okay, so start writing. Sigma 2, please write down. Sigma 2 is not the stress, which is responsible for changing the shape of the component. Sigma 2 is not the stress which is responsible for changing the shape of the component. Sigma 2 is not the stress which is responsible for changing the shape of the component. But it is responsible for drawing the component. And when the component is drawn through the dies, by applying sigma 2, when the component is drawn through the dies, by applying sigma 2, flow stresses are induced on the component. And because of this flow stress is induced, the component undergoes shape change. Next point. So if the drawing stress sigma 2, if the drawing stress sigma 2 is greater than average flow stress, then the stress is induced will be higher than the average flow stress. Then the stresses induced will be higher than the average flow stress. Will be higher than the average flow stress. And hence predicting the exact size of the wire, after the deformation will not be possible. And hence predicting exact size of the wire after the deformation will not be possible. Therefore sigma 2 must be less than or equal to the average flow stress. Therefore sigma 2 must be less than or equal to the average flow stress. So sigma 2 will be less than or equal to the average flow stress. Is this clear? Okay, let's move on to next. We have calculated the drawing stress. Now how much will be the drawing force? How much will be the drawing force?